Good morning, everyone. Myself, Priyadashini, working as assistant professor in the EE Department of R&D Engineering College. Today, we are going to discuss the topic on DSP processor. So, what are the special features of the DSP processor? The special features involves all the functions, whatever we are doing in the signal processing, like convolution, correlation. It can be done that involves the multiplication and addition. So all these features can be covered in the DSP processor. At the same time, the real-time processor, that is very fast accessing of the large values can be done. That is, for example, in the faster Fourier transforms and on, the computation's value will be increased larger. So for that, we need a larger memory as well as the fast calculation is required. So everything can be done by using a DSP processor as early as possible. The special requirements of the signal processors are fast data access and fast computation, numerical fidelity, fast execution control. So fast data access. Why that is faster data access is available because of high bandwidth memory, and it is having of a special addressing modes and memory access, direct data memory access. And fast computation can be done because the multiplier, that is accumulator unit and pipelining instructions are available. At the same time, numerical fidelity can be done easily with the help of the accumulator registers and the guard bits. And fast execution control is available with the shadow registers and the overhead loop registers and all. Faster data access, it is available because of the high bandwidth. The next is high bandwidth memory architecture. The processor mainly uses the hardware or modified architecture because it is having of a separate memory blocks and separate data buses, and as well as to transfer the data from the CPU and out of the to the CPU. And specialized addressing modes. There are two main addressing modes are specialized here. One is the circular addressing modes and another one is the bit reversal addressing modes. That is when compared to the normal addressing modes, and these two are the special addressing modes. The processor also have a special blocks to perform all these operations and all. The circular addressing mode can be used to access memory declared as a programmer can be defined a circular buffer by specifying start address as well as the end address. When the address pointer is incremented, the address will be checked with the end address, and if the end address is reached, the pointer will be loaded with the start address. That is, it will be moving in a circular manner. And bit reverse addressing mode can be used in the bit reversal computation. In this mode, the address is incremented or decremented by the number specified in the bit reversed form. The fast computation is possible with the MAC units, multiplier unit, and the pipelining instruction as well as the because of the architecture, that is VLIW architecture also helps the fast computation. Multiplier and accumulator. The important computation, that is FFT convolution, involves the multiplication and summation of lengthy numerical arrays. And the MAC unit will have a multiplier, a set of register, shifter, programmer containing this MACD program. And DMA of this processor will multiply the content of the program data memory specified by the instruction and add to the sum of the previous product with the appropriate shift in a single clock cycle. The next main feature is the direct memory access, that is the DMA technique. The DMA technique is the transferring of the data between the two memory blocks without involving the CPU. So the CPU can be used for the other task. It is possible with the DMA controller. So whenever we are not depending on the CPU can do some other work. So we can easily transfer the data between the memory blocks with the help of this DMA, which improves the fast execution as well as we can able to complete the work as early as possible. The controller can simultaneously generate the two address and control signal between the two memories or between the memory and the IO. So this is the structure of the DMA controller. The processor is connected with the DMA controller, and the address bus and the control signals has been connected, and the external memory is also connected to the data bus to the external bus. The next is the pipelining of instruction execution. Okay. So in a processor, the pipelining structure, it's used to execute the instruction in the order to complete the execution of instructions. It will be going in a sequence manner. In this processor, instruction execution is divided into four stages. One is the phase one, that is fetching the code, opcode. Phase two is the decoding the instruction code. Phase three is read the operand from the data or the program memory. And fourth is execute the task. For pipelining, the next instruction, that is to improve the efficiency, the pipelining will be carried out in the parallel structure. Fetching is, we have to fetch the instruction and store it in the program counter. Decoding is instruction in the register is decoded and increment the program counter. And the memory, it reads the data from the database and also write to the database, and finally it is executed. And this structure explains the pipelining architecture. For example, instruction 1, fetching, decoding, reading, and executing has been started. Whenever the fetching is completed, it will move to the next F2. F2 is the fetching of the next instruction. And then this process will be keep on going. And similarly, if this process is started, so this will be started. So that is first instruction is completed, its fetching means it will be going to the decoding, and the second instruction will be started with the fetching, and similarly it will be moving with the third and the fourth instruction. So all these instructions are moving in a parallel manner only, so it is not waiting for the one instruction has to be executed and it has to be completed. The multiprocessor architecture will consist of the number of digital signal processors in parallel. We'll have four parallel processor and a main processor and a master processor of 32-bit RISC processor. Each parallel processor is advanced with the 32-bit digital signal processor. Numerical fidelity. That fidelity is help to achieve the mathematical operations of the processor without the overflow and underflow. The error generally occurs when the result of any computation exceed the size of the registers used to store the result. So in order to avoid those conditions and all, this nature of the DSP processor will be very helpful. So it is having a 32-bit accumulator and the CPU register. And especially the 5-4 series of 40-bit accumulator with upper 8 bits is called as a guard bit. The guard bit or use the head margin for the combinations like convolutions and correlations to avoid the overflow. The next is the fast execution control. The fast execution control is obtained by the two features like zero overhead hardware loop and very fast interrupt handling by employing shadow registers. That is, the zero overhead loop allows the programmer to initialize the loop by setting a counter, defining the loop bounds, and the interrupts are also usually given with a higher priority. During the interrupt, the processor will start the current execution and execute the ISR routine. The next is the functional modes of the DSP processor. So what are the certain functional modes? The central processing unit. The central processing unit is having of contains an ALU unit of 40-bit arithmetic logic unit and 40-bit accumulators, two 40-bit accumulators, a barrel shifter, multiplier, that is 17 cross 17 bit multiplier, a comparator selector, and the storing unit. We know what is the use of the arithmetic and logic unit. It is of a 40-bit capacity. It is used to access of all the arithmetic and logical operations, and it is having a two 16-bit ALU and perform two 16-bit operators side by side when the C16 bit in the status register. And similarly, the barrel shifter. Barrel shifter has a 40-bit input connected to the accumulator. So the 40-bit output can be connected to the ALU or to the data memory. The barrel shifter produces the left shift of 0 to 31 bits and the right shift to 0 to 16 bits on the input data. The additional shift capabilities enable the processor to perform numerical scaling and bit extraction. So multiplier and adder. So generally we know what is the use of a multiplier and adder. It is used to multiply the given data and add the data, and the execution can be done faster. It is a single instruction cycle. So within the single instruction, the values will be calculated and stored it in a particular register. The next, the types of register: status register, auxiliary register, and temporary register. The status registers are represented as ST0 and ST1, contain the status of the various condition of that device. whether that is regarding the flags, whether it's overflow or produced by the arithmetic operations and bit manipulations. And ST1 contains the modes, various modes and instruction. Auxiliary register. The 8 16-bit auxiliary register can be accessed by the central arithmetic logic unit. The primary function of the auxiliary register is generating 16-bit address for the data space. Temporary registers are used to hold one of the multiplicands for multiply and multiply the accumulate instructions. It can hold a dynamic shift count for the instruction. The instruction stores the exponent value computed into the register. Next is the transition register, stack pointer register, circular buffer size register, block repeat register, and interrupt register. And the transition register is a 16-bit register. It is used to hold the transition decision, whether we want to move to that particular data or we have to remove that. The path can be decided. Stack pointer register. It is a 16-bit register that contains the address at the top of the system stack. It always points to the last element pushed onto the stack. Circular buffer size register is used in the circular addressing mode. And similarly, the block repeat register, it's a 16-bit register used to specify the number of times of the block of data has to be repeated again and again. And similarly, it will be giving the starting address of the block and ending address of the block. Interrupt register, as we know already, it will be indicating the status of the interrupts, whether it has been in the subroutine or it is in the masking or unmasked. Processor mode status register, and it will be indicating the in what mode the processor is working. And different types of memories. The memory generally on chip ROM, three categories it has been classified: on chip ROM memory, DRAM, and single access RAM. So on chip ROM, the minimum memory address is around 192 K words. It's composed of 64 K words in the program space. On-chip ROM includes on-chip maskable ROM that can be mapped into the program memory or data memory depending on the device. On-chip dual access RAM is it can be dually accessed by program as well as by data. It's a primarily intended to store the data values. The next it can be used to store the program as well. On-chip two-way shared RAM. Program memory and data memory. So program memory, it is especially used to store the program when the cells are mapped into the program space, and the data memory space is addresses. The device automatically accesses the on-chip RAM in addressing it is in bounds. The advantages of operating on-chip memories are higher performance because of no wait states, lower cost than external memory, and low power consumption. The main features of the DSP processor it is having a multiple register, multiple operands, and our circular buffers accommodate the operations very fast, jumps and shifts, chip memory, and interrupt structure.